Hi, my name is Michelle Blade, and I work on permafrost at the Canada-Nunavut Geoscience office located in Iqaluit, Nunavut. The Canada-Nunavut Geoscience office is a partnership office co-funded and co-managed by three government organizations: the Geological Survey of Canada under Natural Resources Canada, Lands and Minerals Sector, Crown Indigenous Relations and Northern Affairs Canada, and the Department of Economic Development and Transportation under the Government of Nunavut. The management board for the CNGO office consists of representatives from all three aforementioned government organizations, as well as a representative from the Nunavut Tunngavik Incorporated. The mandate of the Canada-Nunavut Geoscience Office is to provide accessible geoscience information and expertise in Nunavut. The office consists of a chief geologist, a Paleozoic geologist, a bedrock mapper, a surficial mapper, a GIS specialist, a data dissemination and computer programmer, and a permafrost specialist. In terms of permafrost, the CNGO office is looking to build permafrost capacity and research in Nunavut through, but not limited to, the Nunavut Long-Term Permafrost Monitoring Program. Now, it involves regular data collection from thermistors installed throughout Nunavut in undisturbed areas down to a depth of 15 meters as a way to monitor how the temperatures in these soils are changing and disseminate the data to climate change modelers as well as decision makers for better predictions on future conditions. Overall, this work focuses on revitalizing community partnerships and discussing how future permafrost monitoring will address community needs. Additionally, potential changes to the continuous permafrost of Nunavut is monitored through the water quality sampling program, which is what the remainder of this presentation will entail. Now, Iqaluit, the capital of Nunavut, has had a water quality monitoring program in place since 2004. The data has been collected by Crown Indigenous Relations and Northern Affairs Canada for the past 15 years, totaling 280 water samples analyzed during that time. In today's presentation, I'm going to go through those 280 water samples, do a preliminary analysis of the major cations and anions to show trends in how the water quality is changing over the past 15 years. Here's an aerial view of Iqaluit, Nunavut. You'll see the city in the bottom mid portion of the slide, just north of Frobisher Bay. To the left of the Iqaluit label is the long linear structure of the Iqaluit runway. And overall, Iqaluit is a low elevation, close to sea level, and the elevation increases the further away from Iqaluit that you get. The red text is the labels of all of the different water quality sampling sites in and around Iqaluit. So to start, I'm going to look at these three locations that are located above Iqaluit, Nunavut in terms of elevation. The first is IQUBL for Upper Base Lake. The second one is Lake Geraldine, which is the reservoir that holds the city water supply. And the third is IQAR, which is located just above stream from Apex. The blue linear line is how I've highlighted the Apex River. And to note, just for reference, for the past 3 years, water has been pumped from the Apex River into Lake Geraldine in order to augment the volume of the reservoir. And for the past 2 years, an unnamed lake has had water pumped from it into the Apex River and then from the Apex River into Lake Geraldine, also for the purposes of augmenting the Lake Geraldine volume. So here is a Piper diagram for all three locations previously mentioned. The purple represents the Apex River, the green is for Lake Geraldine, and the yellow is for Upper Bass Lake. Now, the lighter the color, the older the sample is. So that would be back in 2004. And then as the dots get more saturated in color, they become more recent in when those samples were taken. I've also increased the size of the dot, the more recent the samples are, just to better highlight where we are in terms of time for when the sample was collected. Overall, in all three locations, the water is predominantly a calcium bicarbonate type. There is a slight trend towards magnesium, sodium, and potassium in all three locations, and with time, and a trend away from sulfate and increasing the relative concentration of bicarbonate as well for all three locations. In 2018, the sample from Lake Geraldine has a higher magnesium concentration. However, in 2019, the concentration from Lake Geraldine returns to fit along the same trend as the previous samples. So I'm interpreting that 2018 sample as an outlier at this time. On the other side of Iqaluit is the Sylvia Grinnel River, which I have highlighted on the slide in blue. Furthest away from Iqaluit along the Sylvia Grinnel River are two sample locations in the upper left-hand corner of the slide. Those are water samples that were taken in 2004, 2005, and 2006 for a potential gravel source. So relatively short timeline, but gives some context to the historical water quality in that area. Downstream from those is the hydrometric station located at the very end of the Iqaluit Airport runway. Now that station has had water quality samples taken consistently every year since 2004 until present. So looking at the Piper diagram again, the purple represents the sample collected northwest of the potential gravel source. The green is from near the potential gravel source. And then the yellow is that longer standing water sampling run for the Sylvia Grinnel River next to the hydrometric station. The 2004 to 2006 samples from the near or at the gravel source coincide with the samples that were taken at the Sylvia Grinnel River. Overall, they are in line with the samples from the previous Piper diagram that we looked at of showing a calcium bicarbonate type of water with a slight trend towards magnesium, sodium, potassium, and again, away from sulfate and increasing the relative concentration of bicarbonate. Last, we'll look at the samples collected along Carney Creek that starts northwest of Iqaluit and then goes through the city center with an outlet into Frobisher Bay. For visual ease of comparing the water quality locations along Carney Creek, I've grouped them for all of the sites that are upstream from Iqaluit to be the color purple on the Piper diagram. For the locations that are within Iqaluit developed area to be the color green, and for the outlet from Carney Creek into Frobisher Bay to be the color yellow. So for Carney Creek, the water type again at all three groupings is a calcium bicarbonate type with a slight trend towards magnesium, sodium, and potassium, as well as, again, increase in relative bicarbonate concentration from sulfate. There are a few more outliers, though, such as the green dot depicted here for IQCCB for the 2018 sample. Now, IQCCB is located within Iqaluit say limits, and because of the higher chloride concentration, I suspect that the sample was influenced by city water supply, which is chlorinated water. The 2018 sample doesn't go with the overall trend, as the 2019 sample is back within the overall calcium bicarbonate grouping. So that is why I think that one might be erroneous. Similarly, IQCCD from 2005 is located above Iqaluit, or upstream from Iqaluit. Iqaluit, though, has utilidor, but it also has a trucked water service. So with the higher chloride concentrations there as well, it could potentially be from a release from a water truck. Again, after 2005, the samples from IQCCD are again within the overall grouping. So definitely not an indicator of an overall trend going in that way, and more likely that it is an outlier. IQCCO is at the outlet of Carney Creek into Frobisher Bay, and it's also not following the overall trend, as the 2019 data is once again within the overall grouping. I suspect that what had potentially influenced 2018 data at CCB may also be influencing the 2018 CCO location, as the one is downstream from the other one. But overall, as I'm looking here for what the trends are, I consider those outliers, and I'm paying attention more to the overall grouping. Beyond Iqaluit, there is also water quality data available for the same time period of 2004 to 2019 for the Kivallig region. This data was collected by the Kivallig Inuit Association along with Crown Indigenous Relations and Northern Affairs Canada, as well as by Environment and Climate Change Canada. Similar analysis will be done with these locations, as was demonstrated with the Iqaluit water quality data, as a way to understand the overall trend in water type for these areas. Results will be compiled in the Canada-Nunavut Geoscience Office Summary of Activities publication. It is published every year, and there's a link there to access the 2019 publication and the previous years. So Nakurumik, thank you to all of the water quality data collectors over the past 15 years. Without your efforts, being able to understand the trends in water quality type would not be possible. And as well, a special shout out to Sarah Floti for her work on the water quality monitoring in Nunavut, as well as for going through all of the data and compiling it in a usable way. Thank you very much, and my contact information is there below.